optimization, which is 4-4. And this is, should be in your notes, 4-1. And I just learned a lesson that you shouldn't open a pack of Sweet Tarts and start eating them when you start your video. Hold on one second. Okay. It says all optimization refers to is finding the absolute maximum or the absolute minimum. The usual difference between optimization problems and problems we have done so far is that the equation must be written by you. And by the way, just for Jimmy, I was going to tell you what page this was on in your packet, but I do not have my packet with me. Hold on one second. Let me go get it. This is on page 27 in your packet. Alright, we're just going to jump right in. I'm going to let you read all that on your own. Jumping in. A rectangle is bounded by the x-axis. I was trying to make it bigger. A rectangle is bounded by the x-axis in this semicircle, the square root of 25 minus x squared. What length and width should the rectangle have so that its area is a maximum? Okay, so if we look at our rectangle over here, and we just say that this value is x because we don't know how far it is away from the x-axis, this little value here, then this little value is also going to be x because it's the same distance away from both sides. So my length of my rectangle would be 2x. Okay. My height, or my width of my rectangle, is going to be my y value. Now my y value is how far above the x-axis the rectangle is. It's also my y value. My y value here. So if I write my equation, my area is length times width. Well, my length is 2x. My width is the square root of 25 minus x squared. And I'm just going to go ahead and give a quick disclaimer. If I don't make sense, which I probably won't if we're being honest, if I don't make sense, go back and watch Mr. Leckie. He does a great job on this lesson, and I don't feel like I do. So, yeah. So what we want to do, we have an expression for our area, and we want to maximize area. So that means we want to take the derivative, we want to find a prime, and we want to find where it changes from positive to negative. That's a max. A min is where it changes from negative to positive. So if we take our derivative, this is a product rule. So my a prime is going to be 1. And I'm going to rewrite this as 25 minus x squared to the 1/2. So d2 would be 1/2 times 25 minus x squared to the negative 1/2 times negative 2x, chain rule, plus 2 d1. Alright? And I have to set this equal to 0 and do a sign graph, so I have to make it a lot prettier than it is right now, because right now it is not pretty. So let's clean it up. Initially, I see that my 2 and my 1/2 cancel away. So essentially, I have negative 2x times an x, that's a negative 2x squared. Then I have 25 minus x squared to the negative 1/2. I can move that to the bottom and rewrite it as a square root. Changed colors. Plus 2 times the square root of 25 minus x squared, coming from over here. I am adding two things. These things are called fractions. I'm adding two fractions, so I have to get a common denominator. So my common denominator would be the square root of 25 minus x squared. The first one did not change from here to here, so it stays the same, negative 2x squared. The second one did. It was a 1, now it's the square root of 25 minus x squared, so I do times the square root of 25 minus x squared on the bottom and on the top. Whoops, squared. So when you do a square root times a square root, you're essentially saying the square root squared. So that's 2 times the square root goes away, and it's just 25 minus x squared. So if we can clean this up a little more, let's put it all over 1 square root. And I've got, if I can go ahead and make that 50 minus 2 times negative x squared to x squared. And then I'm going to combine my like terms here. Hope I'm not losing you in the algebra. So that's negative 4x squared plus 50. Now, remember that the critical numbers occur where your derivative is either 0, so where, where'd it go? So where negative 4x squared plus 50 is either 0, or where it's under 50, where it's undefined, so where the square root of 25 minus x squared is not equal to 0. Okay? And more specifically, where the 25 minus x squared can't be negative either. So essentially where 25 minus x squared is greater than 0. So if I come over to this one, I minus 50, so I got negative 4x squared equals negative 50, divide by negative 4, x squared equals 12.5, so x equals plus or minus the square root of 12.5. And then over here, remember you'd have to do a little sign graph, but if I just solve it for a second, let's just pretend solve it, I would get x equals plus or minus 5. And if you look at your picture, come up here, those are the endpoints of my rectangle. So if I did a sign graph for that, I would get between negative 5 and 5, which is my domain of my problem anyway, because I can't make a rectangle bigger than my semicircle. Did I say the endpoints of my rectangle? I meant the endpoints of my semicircle. So I get x equals plus or minus the square root of 12.5, so I'm going to do a sign graph. And my x value is actually going to be, I can just use this positive one, because whatever I get for the positive one, the negative one's going to be the same. So I'm just going to use the positive 12.5, square root of 12.5. And I've got negative 4x squared plus 50 over the square root of 25 minus x squared. That's my a prime. If I fill in 0, I'm going to get 50 on the top and 25 on the bottom. That's 2, so that's positive. If I fill in a number bigger than 12.5, how about 10, I'm going to get a really big negative number on the top, and it can't be bigger than 5. So I'm going to have to stop. How about 4? 16, negative 4, negative 64 plus 50 over the square root of 9. So that's negative. So my derivative is going to go from positive to negative, so it's a max. And so my x value is the square root of 12.5. And my y value, if I fill in my square root of 12.5 back in, did it ask me to find the actual max, or did it say what length and width? So yeah, it did. So I fill in my x here, so it would be the square root of 25 minus the square root of 12.5 squared. So 25 minus 12.5 is just the square root of 12.5. So it would be a square. So I want my dimensions to be the square root of 12.5 by the square root of 12.5. So, and you would write it, the way you would really write it for calculus is on the interval 0 to the square root of 12.5, in other words, here, 0 to 5, the derivative is greater than 0, and then on the interval, I'm running out of time, this lesson may be in 2 videos, the square root of 12.5 to 5, a prime is less than 0, so therefore, a prime has a max, or, wait, no, therefore, the square root of 12.5 is a max. I hope that didn't make, I don't know how much sense that made. If it didn't make sense, tell me and we'll go it again in class. And on example 8, I'm just going to do that in class because that one's very tricky. Very, very tricky. So we'll just do it together tomorrow.